already you're doing the training, but hopefully I can share with you some things that like I learned, wish that I had known when I was getting started coaching that FLL team. My wife couldn't be here today; she was the other coach. She did a lot of the innovation project stuff, and I led a lot of the robot stuff. But we'll go ahead and get started. There we go. All right, so this is our team. I've got to show them off because I love these kids. We were the Knights of the Round Lego. We were a 7-person team, ages 9 to 13. Participated for 3 years, and last year we actually attended the World Championship in Houston. And I will say briefly that coaching the team was one of the most fun things that I've ever done. Knew most of these kids beforehand, and just getting to spend time with them each week, seeing them learn and do things, even over 3 years, watching their innovation project presentation the first year and now, and seeing how much they've learned and grown. It's just so much fun. It's so great for them, but it's also a blast for the coaches. And those are my two, son here and my daughter there. And like I said, ages 9 to 13, we actually had kids that participated. I think maybe the young is 7 because we don't really enforce the lower bound of age. So what will I talk about today? So I'm going to talk briefly about the major components of FLL Challenge, the robot game, the innovation project, cooperation and judging, what that's like when you get there. And if you're not familiar, if you haven't heard the word cooperation, it's a mashup of cooperation and competition, because in FLL it's not super competitive. You're not out to destroy the other team. It is highly cooperative. And I wish I had a video clip in here. I didn't put it in, but a couple of years ago, the theme for the year was energy related, and there was a cooperative mission model, which always won on the board if you see it down there, where there was like a hand that represented a smart electrical grid that had to you had to raise it, and if the other team raised it, it was like 2 hands giving the high five. And the 2 teams that were at the table, our team and the other one, had their robots raised it at the exact same moment, and it was like they were really getting that five. And it was just, to me, like watching that, it was like, oh, this is the cooperation on full display, because both teams celebrated and happened, things like that. It's just really awesome. I'll go over the core values of FLL, and then the bulk of it is tips for coaching a team. Things that we learned that worked for our team. Your team might be different. Do what works for your team, and then I'll open it up for questions. Or if you have questions along the way, please raise your hands. So the robot game, if you've seen the map down there, the robot game is what most people recognize when they think about FLL, if they've seen it before or got it before. So you're going to build a Lego robot and attachments on that robot, or however you choose to do it, to autonomously complete as many missions as possible in 2.5 minutes. This is what the board looks like. You'll have one if you don't have it already. You get it soon. The map and all the mission models that go on. But at competition or cooperation, there will be 2 side by side. So those 2 tables will be there, and 2 teams will participate together. Each mission that you accomplish is worth a certain number of points. That should be in the rule book explaining, how it is that you have to. And in case it isn't clear, the missions and the map change every year. So you're not going to be doing this one year after year. They'll change them. And then there's the innovation project. And this is the part that I didn't really understand before we came here 3 years ago. But it was just kind of like an add-on, a little extra fun thing to do. But it's actually a really important part of programming. And I would say where our kids learn the most. So each year you identify a problem related to the theme or the challenge. This year's is archaeology, I believe. You'll identify the problem, create a solution, or improve upon something, test it, and gather feedback, and iterate on a solution. This might sound kind of daunting. It can be, but you'll break it up into little pieces and get it done. And it doesn't have to be really complicated. Our first year, I think we started out way too complicated. It was energy themed, and I worked for a company that works in the energy sector and was able to connect them to some other resources. It was like, God, we set up too much. So keep it simple, but try to make some more slides. Not yet, but so I haven't been looking too much at the FLL material since I'm not coaching a team this year, but I assume that they've given you a challenge to find something. And is the theme is archaeology, right? To find something, a problem that archaeologists face, or something like that, something they do that you can improve upon. So, and that honestly, finding the problem can be one of the most challenging aspects. So the season order, there's a kickoff in early August, which has already happened. We challenge set and information on the project. Does everybody have that? The challenge set, the information, the rule books, things like that. And then there will be qualifiers this year. They are mostly in November, with some in December. And your team will attend an all-day fair. And then the last email had information on how to sign up for that, which will happen in September. That's a one-day event where you'll do the robot competition. You'll present the innovation project, be judged on it, things like that. And 2 to 3 teams, I think, for each qualifier advance to the region, which is kind of the state competition. It's not state, it's Kansas City separate here, but 2 to 3 teams will advance to that, and that I think is in January. I hope I have it right here. So I think it was in February the past 2 years at least, but I may have that wrong. But you'll have emails from Ron, I'm sure that have all the correct information. And then there are advancements from that, a few. And those competitions that take place are April through June. Those are not in the St. Louis area. Those you travel for. So the World Championships for all the first events together are in Houston years past. I think they'll be in Houston again this year. But then there's also other events that get posted around in Florida and things like that. So there are a few teams from Missouri that will advance to these things. So the robot game and competition on the day of the event, your qualifier, you get 1 practice run, and then you get 3 officially scored runs. The highest of the 3 runs is what your score, what counts as your score, and how you'll be ranked in the robot game against the other teams. The referees at the table, this is one of the referees who's no longer running away, Andrew, but they will score the run, couple kids through running the match. But they will also score the students on their core values. So do that quietly. If the team is there, not representing the first core values, they might get marked for that. But the referees should tell the kids they really cheer the kids a lot and have a lot of fun. This is our kids taking a picture of Andrew. They love seeing him in competitions. They're really friendly. If you've talked to Fred or any of the other referees down there, they're sure great. But then there's also the presentation and judging. Because everybody thinks about the robot game, but the presentation and judging is actually where most of the points that don't come from. So the students will take their innovation project, put together a 30-minute judging session. They'll go into a 30-minute long judging session where they'll spend 5 minutes presenting their innovation project, 5 minutes answering questions to the 3 judges about that. Give a 5-minute presentation of their robot design, and then 5 minutes of Q&A, and then the judges leave that. And there's some time that doesn't add up to 3 minutes. There's some time for setup. And the judges will give feedback on it. It's really friendly. They shouldn't stress out about it. I think sometimes they'll let parents and coaches go in with the students. And you have to sit where the refs can see, or not the refs, the judges can see you, so that they know you're not guiding the kids, because the kids really should be doing all of this. And they will work with the kids. We understand that, for some of these kids, this is the first time they give their presentation. Also on competition day, there are team pits, so everybody will get a table with a couple chairs. Where you can put together a display board and show off your innovation project, show off your robot, explain your project to their teams. Some teams will bring buttons, stickers, little trinkets or something that they've made to trade. Our team got one of those button presses from Amazon to make buttons for that is fairly cheap. Don't stress about that. But it's just a fun thing to do at competition. That gives you a place to store your things. Think of your shop. So the core values, in case everybody doesn't know them, there's a lot more of information on this on the course website and stuff like that. Teamwork, inclusion, impact, innovation, discovery, and fun, which was often our kids' favorite core value in the past. It's fun, but as they were, they grew to enjoy what discovery impact. So these you'll try to represent in everything as you go, but it's a good thing to remind the kids of, talk to the kids about it. The judges a lot. The kids, what's your favorite core value? They'll look for these things to be exhibited. So there are things to keep in mind. I guess any questions about competition day?
Yeah. So do we bring that forward to the competition, or do they have them there?
They will have them there. So if you have like a practice table or something like that, you can bring it. A lot of times so that the team can practice. A lot of times the practice getting set up for each that might need to in between runs, try things out, make improvements. But they will have their governance. And if there's anybody that doesn't have a table, I actually brought our little one that splits into 3 pieces. It's like lightweight. Just come up with me afterward if you need one. I don't need anything.
Does Rhonda know that you have one strap?
No.
No.
I'll tell you. Yeah.
She promised, like, we still had it, we didn't.
Oh, okay.
Okay.
It's one that actually I have plans for it from somebody online. It's made out of glass, which is what like yard signs and stuff are made out of. So it's lightweight, easy to carry. Yeah, somebody's got plans online, but then I have a video of modifications that I made and I could send you. So any other questions about that? Cool. Just a reminder, do what works for your team. Don't take anything that I'm about to say about tips, things like that as prescriptive. You need to do this. This is what worked for our team. It took 3 years to figure out what worked best for our team and for our students. Do what works best for your students, adapt and go with it. So I guess as an introduction, like first has this idea that kids do all the work. This isn't something where like you're just bringing them along for the ride. You're bringing you along, right? So if the kids do all the work, then what do the coaches do? Are we just there to make sure that nobody stabs anybody or what? So the way I've summarized this is that the kids make every decision to put a project. Their missions, their attachments, their project, education. They put all that together. They do all that. If I'm trying to decide this is something I should help with or whatever, I'll often go back to that and say, well, is it consistent with that? So some of the biggest things that we've seen as our role in our meetings, was to keep kids focused. I don't know if you've noticed, kids can easily get distracted by things. We had several teammates this year that would spend more time talking about, well, what if we get to the World Championships? What will that be like? Eventually, I had to say, hey, listen, the teams that get to the World Championship don't stand around talking about World Championships. They warm up. But we also help write a roadmap for the kids each year. It's a big project. It can be a lot for them. So it's tough to guide them and say, okay, we need to first find the problem. How can we research it? We'll sign out some homework and say, hey, everybody go. Last year was about like exploring the ocean. Go to the library, go online, go on YouTube with your parents, find some information, try to find a problem, back with some ideas. And so, everybody's goal for the next week might be bring back one type of expert that explores the ocean. And then we also try to equip the kids with the tools that they need. Last year, our team said, this was pretty advanced. I said, we want a program microcontroller to do this. It's great. You've done this before. Some of them, yeah, okay. So it's what I do for a living. So I want kind of resources to help teach them how to do that so that they can have the tools that they need to do that. That's going to look different for each team each year, what resources they might need to accomplish their project, but they always. And then last, but really it's one of the most important things is making sure that all the voices are heard. In a group of kids, it's easy sometimes for one kids to just be like, have a great idea, share it because they don't feel comfortable, but we try to make sure that it's an environment where the kids feel comfortable sharing their ideas, that the ideas are heard, and that there's not too much conflict. And I also want to say, don't forget to educate the parents about the program. Make sure they understand the game. Make sure they understand the importance of the innovation project. Everybody does this for different reasons. Maybe they're just thinking, hey, we want to do the robotics. Make sure the parents understand it. It is still a hard thing to understand. Even at world championships, oftentimes my wife or I would stand next to other parents and narrate, okay, they're going to try to do this. Oh, that didn't work because it's complicated. It can be hard to one tip that I have that the judges recognized for our team several times was, I think that it's beneficial for everyone to do everything. And that sounds like a lot, but it doesn't mean that everyone has to do everything to the same. You might have some kids that are really great at programming, they're really mechanically minded, really great at designing a robot, really passionate about doing this. Right. Let them run with it, let them do this. But one of the things that we wanted to make sure happened on our team is everybody learned about the missions in the robot game. Everybody contributed ideas. Everybody. Now, for some kids, that meant that they built complicated blocks for how to follow a line. And for others, it meant that they used those blocks to put together a program and say, oh, I need to drive straight for 30 centimeters. I'm going to drag out that block and do it. But everybody worked with it. And I think that's important to have everybody interacting with the students of it. And then one of the things that we always try to do is to get everyone participating in the robot. So they will let you change out people that are operating the robot. And so we made sure that anybody that wanted to did that. We had somebody new on the team this year that was not really comfortable with it. So she set up and ran the very first mission. So she had time to get the robot positioned where it should be, make sure everything was set up right, wasn't rushed and things like that. But we wanted to make sure that everybody was involved. And then also that everybody participated in the presentation. We had younger kids who didn't want an 8-year-old stepping back while a 13-year-old led presentation. It's good to get them exposed because it's important to remember that the robot is important. The project is important, the kids learning and the kids participating in it is what's important. So don't sacrifice some of the kids learning for the finished product. Yeah, I guess that's what I want to say. Remember learning, having fun, working together, solving problems, communications, and core values. Those are the really important things. Those are the things that our kids will take with them from this and apply to all kinds of business. So make sure that you're focusing on these things. And then I'll share some robot game tips about doing the robot game. This connects to what we just talked about. Don't let the robot game become something that only a few kids do. Get some kids that were a little timid, not sure about it, didn't understand it as well as some of the others. Make sure that they're involved too. And I guess this is a repeat of things that I already said. But yeah, just make sure that they all stay involved. This is something that we didn't learn until later on, but learning how years work is important. I forget as a more mechanically minded person, not everybody understands years and year ratios. And one of the most helpful things for our team was the Isagawa books. Yoshio Isagawa has all these books. This is the cover of Lego Technic, non-electric models. It's all kinds of different books. And they're really simple things that might just be like little grammar notes. And the kids can build and learn how different linkages things, and they can just put these things together. They're so much fun. That's a QR code that I think should take you to the Amazon authors page. He also has a cool Facebook page where he just posts stuff hey, Lego's got this interesting new piece. Here's some fun stuff you can do with it. that is a lot of fun to see. But I highly recommend the Isagawa books. I think my kids can find this point. And then I think it's also important to remind kids to keep it simple. A lot of times kids would think of a really complicated way to solve a machine or something. Encourage them to explore simple solutions. Encourage them to experiment with the robot or without the robot to see how reliable something might be. We would oftentimes task kids with, okay, I know you want to do this with the robot, but try to just make a little thing. We give them one of the Lego Technic frames and say, build something that you can just push up in the mission model that does what you're thinking. And test where you spend all night building a complicated intention. Test that and see what it does. Find the simplest way to test a video. This is a picture of our team's robot from 2023. It wasn't driving straight like they thought it should. And they were trying to come up with, why isn't it doing that? And eventually they thought, maybe it's front heading, maybe it needs more weight back. So they were going to build a new robot with back. It's like, why don't we put something heavy back and test it? Oh, that's a really good idea. So they put a soup can in back and tested that. And guess what? It drove straight. And so they knew what they needed to change based on that 30-second test. And the process of doing that experimentation is something that you want to keep in mind because that's helpful for your robot game presentation or your robot design presentation. This is kind of a correction, something that I don't know how other people feel about this, but I went into it my first year thinking we should not watch YouTube videos of other teams completing missions. Because we don't want to give it away. You need to come up with your own solutions. What I've realized since then is that repeating what you see on YouTube is not easy. A lot of times you're going to see teams that have been doing this for a long time, and it's not easy. Even if it looks easy, it's complicated, and you can't run out by trying to replicate it. You might get inspired by seeing another team do something fun. So I'm not saying that you definitely need to watch YouTube videos, but our first year was no, you can't watch those. That's not an issue. And I think it's over the opposite. I guess know your students too, though. Some kids can be overwhelmed. I see it that really like great team or something crazy. So I say that I'll keep know your students. So this is a picture actually from the championships of my son and my daughter with FS and Jenny, the team in Spain. And they've won the world championships, things like that. Seeing their robot, it is crazy if you look it up. But it's so much fun. But you can compare and be inspired by it. Kids have spent time on trying to replicate some of the stuff that team has done, and they've learned a lot from it. Robot testing and iteration tests. Always test multiple times before you make changes. This is one of those things where we try to help guide the team in their meetings. A lot of times something will not work, and it didn't work because of this. Let's go make changes. Well, if you tested it 4 times, it worked. 3 times out of 4. It just didn't work the first time. Yeah. So they'll oftentimes want to run away and try to like rein them in, help them in that way, where they make the changes, but we'll just slow them down a little bit. Whoa. Yes. We've also had to teach them. Sometimes it's simple stuff that like we intrinsically know as adults we learned along the way. But we always had to say to our team, split the difference. Because if driving 30 centimeters was not far enough, do 31. So I looked at it, you need to drive a lot further than 31 centimeters. So we've had to teach them the process of, 30 wasn't enough, try 40. Oh, that was too far. Okay, go down to 35. That was too short, 37. So split the difference, little things. Leave room for error. A mission that doesn't work unless things are perfect is probably not a great design. Encourage them in that. Not to blame it on the robot like my son is probably doing. He's did what it's supposed to be. Well, no, did for the one part. And then another tip that I have is use your phone to record video test runs at times. Put it in slow-mo mode. Watching the video back in slow motion can really help kids to see what went wrong. A lot of times you'll have 4 kids watching the robot test go. and they'll have 4 different ideas of what went wrong. And they'll watch the slow motion video back that they recorded, and they'll go, "Oh, we were all wrong." It was something completely different. So that's something that can help. So helps with accountability. So you've got 4 different opinions about what went wrong. They can argue. So that's a helpful thing there. Don't forget to practice the robot game. It's not just about getting the robot, but it's also about the kids doing the changes of the attachments and the pit, learning what to do when something doesn't work right. They have to learn the ability to see when the robot's wondering, check, or know what to do when things don't go wrong. It really helps practice. We sometimes will, a few weeks before, encourage the kids to stop making changes. Sometimes it's not going to work right. Just go with it and learn how to deal with it. And that's really helped them well. And then lastly, make sure that you enjoy the vlog. I have this on there because 2 years ago we made it to the regionals. The practice run with the robot went great. Almost everything went great. The first official run, I swear, like the third, once they knew the robot was capable of. They spent an hour and a half stressing about it, trying to fix it. Second run also didn't go well. They spent some time stressing about it and said, "You know what, we're just going to enjoy it and let it happen." Plug the robot in, let it sit. Guess what? Battery. Last run, almost perfect. Went great. And what we learned after the first year is to try to avoid making changes to the robot or unless it's absolutely necessary on the day of the competition, so they can enjoy it and focus on celebrating what they've accomplished instead of saying, "Well, we got 200 points right now, maybe we can get 250. And every team's different. Your team may enjoy that. That was stressful for our team. So we encourage them not to do it. Ultimately, it was all their decision, but we encourage them. Like I said, your team might be different. I've seen teams who just had class that they have coordination, changing things up, like trying to do new missions, like half rebuilding their robot. It's whatever you can do. Do what we're doing. Some innovation project tips are focus on telling the story of how you developed your invention. Focus on iteration. It's not so much about the invention or the improvement that you made, but the process that it took to get there. One thing that our team learned this year is that having 1 or 2 experts that work with you to get feedback is far more valuable than lots of experts. We actually, through connections of friends, found this lady, Missy Wise, with Team Orca, who works in ocean exploration, but also protecting the Indian River moving down there from pollution. And she was amazing. She would listen to the kids and then even take it to other people in their organization and say, "Hey, they sent me this email with questions. What do you think?" And she would send us feedback. And it's fabulous. This is their innovation project from last year. It does not have to be that complicated. This is like a culmination of 3 years of working on it to get here. We put together a display. This is what they had at competition to show off their project. A little award in a science fair light. This was their project. This is more advanced than most. It can be a Lego model that demonstrates. It doesn't have to be super complicated. Don't lose sight of how you iterated. A lot of times we found that our kids forgot all the improvements that they made along the way. So one of the things that we started doing 2 years ago was we had a historian each week, and we had a notebook. And their job was to keep a log of what the team did that week, what they changed, what they improved upon, what they did. And then when it came time to start prepping the presentation, they could look back from that and say, "Oh, this is what we did." We actually had a Polaroid camera. We would take pictures sometimes and stick it in there. It's the simplest thing to keep track of it. And it helps to show how you got feedback, how you tested your idea, how you improved upon. Not just your innovation project, but your robot design too. It's important that it helps the kids keep track of that. This is one thing that our team happened upon this year that I want to share, because it works really great for our team, in case it works well for your other team. In your innovation project presentation, a lot of teams do skits. I believe they're encouraged to bring a skit. Our skits were fairly long the first 2 years. This year, they decided just to do a really short 30-second skit to introduce the problem that people would explore the ocean face that they try to solve. Then they presented their project. When they did this, they broke it down into 1 to 2 sentence bites, and they would all line up, all 7 of the kids. One person would do their 1 to 2 sentences. Easy, small chunk to memorize. You don't have to memorize it. So they set as a goal. They said this year or third year we want to do this. Right? So it made it easy for them to memorize. And then the next person down the line would give their bit to the next person. And it would just loop through. It was actually really interesting to watch the video when they presented it, especially. And the judges quickly figured out only one person would finish up the next person. And then the feedback they got from regionals was, or not regionals, qualifiers, well, what was the impact? And they added a 30-second skit at the end to demonstrate the impact. If we can actually show you their presentation here. This is 5 minutes long. It might be hard to hear. We'll remind that here this finish. Creating that how it thinks together. Yeah, I know.
Yeah, it's coming out up there. That's what it is.
So I'll narrate through. So they just did their sketch. It was really brief, where their innovation project was to monitor pollution with this box sensors in creeks, so you could tell before the pollution got down to the big Indian River Lagoon, what little creek or tributary did it start with? And so their skit was like, oh, it's a beautiful day in Florida, but the water's gross and all the fish are dead. Where did the pollution come from? Don't know. And that was basically it. And they gave their presentation, and at the end, they redid the same skit. Water's gross, all the fish are dead. Where's the pollution coming from? And they're like, hey, we're team worker. Let's check the network. And you look at it, and it looks like it's coming from Sam's Creek. Let's go send somebody to investigate and find out. Really demonstrated the impact well. And this worked well for us. So experiment. Don't take one thing that you see online and say, okay, that's how you guys should structure your presentation. And practice answering questions. We found that our kids really didn't know how to answer questions from the judges well. So we would task them to tell friends and family about the project season long. Tell them about simple questions they ask, answer it. If you don't know, come back and ask the team next meeting. Write it down, bring it back. And then we would ask them questions about their project. They get frustrated with us sometimes because we would ask them questions that are like, you know this, you've been here for the next 6 weeks. You know what's going on. It's like, yeah, you need to know how to answer this question. So that was one way to develop it. And then I think I have some robot presentation tips. Through your robot design, have a process for coming up with the robot design if you can. Encourage the kids to make a list of what qualities are important. What do you think your robot should look like? How should it work? Have the historian record that in the notebook. And in that notebook, don't forget, how did we learn from your design? How did we carry out? What didn't work? What might be different? The judges will want to know these things in the presentation. Don't stress about it. You can build your own robot. You can use one of the pre-built ones that you see online or something like that in the first year. I would actually maybe even encourage and suggest that you really can't write it for the first year, but use the advanced driving base or something that like gives you. But and then the judges also want to know, how did you select the missions that you decided to do? How did you decide on the order to do them in? How did you test them? That I think I heard the judges ask me, so like, well, how did you decide when you were done with the mission? And the kids in first year were like, well, I don't know. And by the end, they were like, we tested a number of times, but we never stopped working. And saw improvements which we make. We would do that. And then so they were often asked, what would you do different next year? To show that they're understanding, they're looking at it. They're not just saying, this is our robot, it works, we're done. So ask them a lot of these things as you read it to help prepare them. I think that's all that I have prepared. Any questions or anything I can get back to?
So on the innovation project, do they share coding on the stuff or is it, are they not like, do they come up with non-Lego things for that?
Yeah, so the question is, for the innovation project, is that something that they code or don't code? Do they use Legos? Is that all separate robot? That's usually not a robot considered. That's something that solves the problem. So I was talking to our kids about the archaeology one, and well, if you were doing it this year, what might you do? Going, oh, well, let's think about things that you've seen archaeologists do. You could use. It's like they've got those boxes with screens that they use to like sift stuff out, but maybe there's an improvement you could make there or something. I would say it's oftentimes not a robot. Not this past year, but the year before, the theme was about sharing hobbies or the arts and finding ways to share those. And our team's project was actually pedestals that you would put along trails in parks because they wanted to get more kids hiking and doing things outdoors. That had, if you've ever done the throwing where you take paper from the relief or crayon on it, it was like that, where you would take a piece of paper at each of these stations, put the paper in, rub it with a different color crayon, and at the end they would all layer together to create a picture. And it was just like get kids hiking, but very much not robotics, no programming. It's kind of better, I think, if it's not like they're doing enough robots programming, right? But yeah, it's a lot of times not robotics related. Could be, I guess. It could be.
Yeah, I guess it's part of their solving.
Yeah. Yeah. They don't have to. Really common.
To piggy off the tail end of that statement, about the problem of solving. In the couple of years you were doing this, was there any particular way of finding a good question that seemed to work well with the kids? Obviously, YouTube shows you many things, and Google shows you many things, but what seemed to work to help the kids get focused on finding something that they thought was a problem?
Sure. So just to repeat the question, I think it was basically how do you help the kids find a problem? Is there a particular process that helps them find? I would say this last year they were kind of a lot of times what you might want to do is start with an expert. Start finding somebody, listen to them, ask them what problems they face. They asked Missy at Teamwork at this year, what problems do you have? And she gave them a list of problems that they faced and they went with that and found solutions. The year before, sharing hobbies or activities for the arts, they were actually able to come up with that a lot on their own. We like to hike. How can we help with hiking? And I think their two biggest ideas were a hat with air conditioning. And then the other one was this thing that's kind of like a storybook walk. If you've ever done one of those at a park or like the pages of book. And they took the storybook walk and ran with it. Yeah, I would say finding an expert, finding resources, going and finding a book, and just having them say like, look at it and say, what problems do you see? Maybe just directly ask problems do you face. I think there's resources downstairs for different places in the area, like Healthy Mountains, like that. I'm sure that if you connect with those people and say, what kind of problems you face, maybe they'll have ideas for you. And it might not seem like it's really strictly related to the problem. And that's okay.
Archaeology is archaeology, right?
Yeah, maybe they'll say our biggest problem is people coming into the areas that we're trying to excavate or protect. And you're like, well, that doesn't help you discover anything. Protecting it's important.
Yeah, that's
So maybe it's something like that. Be really, I don't know, open-ended about it. Share or sue lots. Okay. Yes.
Potentially work great, so It's your home table, and you'll travel to the beach, and in home mode as well.
Yep. Yep.
Building tolerance, I guess.
Yeah. So the question is, how do you help them cope with variability on the table? That things might change. And part of it has been just to remind them when you has to be super accurate. That might not be a good solution, but it's a difficult question to answer because I don't know that we ever solved it. Because of this, our team would oftentimes see the robot work great on our table. And then the next week we'd set it up again and it would work differently. And we would almost like alternate between like, well, fail this way this week and then next week fail that. And then qualifiers on nice indie mark tables, it would behave differently. And at one point last year, I placed an order for an indie mark table and it's like, we're going to remove that ball. And then cancel the order because I was like, yeah, it's got to without it take a break. No. So I don't know that it's been to encourage them to look at solutions. There are tips online. I think it's Prime Tutorial. There's a tutorials and FLL tutorials. It has some tips. One of the things that our team wanted to do is they would always position their robot so it's backed up against the edge of the table, make it straight and square. And before the robot would go, they would kind of drive backwards for like 0.2 of a second so that it would push itself against the wall and make it itself square up. They found that tip in a YouTube video. They did things like that, but they also came up with a system where you can see little like leaves on the table in the home area, and they numbered those. So like the thick lines were like 1, 2, 3, and then the thin lines were decimal places. And the right or the left edge of the robot was 1, so they were like, oh, this is 2.3 R, and they knew to line up the right side of the robot with 2.3. So like they come up with solutions to some of this, but I don't know that I have a really good answer other than encouraging them. It's not going to be perfect. Even at World Championships, we found the tables were different. They weren't used any more tables than the robot. Very different. I think it is a frustration. I don't know why.
So does the final, like, for the innovation part, does it have to be a object that you give to them, or?
No, so the question is for the innovation project, do you have to have like a final physical prototype or something like that? I think it could be a sketch or an explanation. I think it's good to have the tickets. I don't know that you're required to physically put something together or have something, but it's beneficial for them to explore to something. So our progression each year was oftentimes we would tell the kids, okay, you've got lots of ideas. Homework this week is everybody draw a sketch of what you think this is going to look like. Bring back and show them all. Those would go into the historian and look at it. And when they were prepping the presentation, you would have those to look at. Then they came up with a more sophisticated look at and they go and discuss it. They put something together in free form on the iPad to like demonstrate the idea. It doesn't have to be anything physical. Maybe it's not even an idea that's physical, but it is helpful. Our prototype the very first year was literally a cardboard box painted to look like what they think was movie. With I think we went to Dollar Tree with button lights, and they could put the red one, turn it off, turn it on, push the green, turn it off, and turn it on. That's how they demonstrated their idea. I think it is helpful to have something, but it could be a picture, drawing, something. Yeah. So the question is how often and how much to meet. We met every week for 2 hours typically. We would spend like the first 30 minutes to an hour working the innovation project and then the rest working on the money. later in the season, it could sometimes turn into like a 2.5 or 3 hour meeting if we needed to like get things done. You know, do what you can. Doesn't have to be a whole lot. We very rarely met twice. The first year, it's a little late for this now, but we met during the summer just to like go through some of the latest tutorials on how to use Spike Prime, because a lot of kids haven't used it before. And did like a summer boot camp where we met once a week for 4 weeks. And then next year, at the end of the season, they made a list of things that they wanted to learn for the next season. This summer boot camp where we did that. So we kind of focused on the skill development during the summer. So it was just about the project during the year. Start wherever you're at and don't stress about it. Like I said, the important thing is that they're learning. So if they're learning and they're doing this and developing in an hour a week, that is important. If you can do more, do it. I think we have another 15, so probably gotta work for that. I'll be around if you have any other questions. Feel free to come to me.
Thank you.